Hi guys, this is your notes for 57 on rational exponents. So we started today with two calculators on our screen, and we see that the relationship between fractions and our square roots is developing here. So the main idea is this. If we have something like a over b as our exponent, what happens is the denominator becomes the index. So the b moves here, and the a stays as the exponent. Right? So what we would say here is that, for example, the 3, let's see if we can make this a little bigger here. The 3 moves to become the index, and the 2 stays as the exponent. Right? What this is showing here is that you can either, as long as the 3 is the index, the 2 can be either outside the parentheses, that's fine, or it can also be inside the square root. So because multiplication and division are the same, we can do whichever one suits us best. Right, so in this case, we know that the cube root is 3, so that becomes 3 here, and the squared, so 3 squared will become 9. In this case, the 2 would mean that we are have an index of 2, and then the 3 stays on the outside. I know that the square root of negative 16 is 4i, and we know that that is being cubed, and so we have negative 64i. That's what you would get if you had 4i times 4i times 4i. Right? 4 times 4 times 4 is 64. I squared times I squared turns into negative 1, so negative 64i. Right? So what we're saying is that the denominator becomes the index. So if I was going to write these in radical form, I'd have 6. It goes out in front, so I'd have square root, or root 6 of x to the 1 power. Of course, I don't need that 1 there, so I can just leave it like so. Go ahead and try numbers 1 through 4 on your own. Alright, so if I was working on 5 through 7, just so we're clear, this is 343 to the 1/3 power. So what that means is I would take the 3, put it out in front. It's the cube root of 343. I know that I'm trying to split this up, so I got 7 and 49, 7 and 7. These 3 together make 1, 7, because I'm looking for a group of 3. There's none left over, so my answer is 7. You can try these in your own page. So this would be 49 to the negative 1/2 power. This is d to the 1/4. And then this one is in radical form. You can see the whole thing there. All right, with simplifying, our exponential rules still apply. So we know that if we have something like x squared times x to the 4th, that we add them and we get x to the 6th, or something like x to the 6th divided by x to the 3rd, we would get a to the 3rd because we're subtracting there. So we want to make sure that we're writing with positive exponents. We're using the exponent rules. And then it says only integer exponents can be in the denominator. So we can't have any fractions. So this problem here is a to the fourth, I'm sorry. This says a to the 2/7 times a to the 4/7. So I see here that this is like this problem here, where we add them together. So I would say that this combines to give me a to the power of 6/7. Right? So it says only integer exponents can be there. So what I'm going to do is I'm also going to turn this into 7/6. Right? So both of these answers are correct because there's no denominator here. This is b to the negative 5, -5/6. So the 6 goes out in front. And I have 6√5b -5. The one thing that you want to focus on here is that we can't have a -5 there. So if we take a step backwards before this step, and we turn that negative into a positive, we can do that by putting it 1/b to the positive 5/6. Remember, a negative exponent means that you have a fraction. So we have this one here. From there now, we can work with 1/6 of b to the 5th, right? Remember though that we can't leave a root sign in the denominator, so I'm going to multiply times itself, b to the 5th. What do I do to the bottom? I have to do to the top. So here I would have 6√b to the 5th. And then we have our square root, and our 6th root, and our 6th root would cancel. And we'd be left with just b to the 5th power on the bottom. That would be my answer for number 2. Go ahead and try 3, 4, and 7. Not sure why that's called 7. Then you can take a look at your